We are descending 5,000 meters into the Atlantic abyss. At this depth, the temperature stays near freezing, and the sun's reach is entirely extinguished. These are the heavy, grinding teeth of industrial deep-sea mining machinery. This unmapped ecosystem faces the immediate prospect of being carved up by operations like this, alongside the shifting chemistry of a warming ocean. To study this environment before it changes, 50 people are living aboard the research ship Meteor. It is a floating laboratory stationed in the middle of the ocean, a 4-day journey from the nearest rescue port. Chief scientist Torben Reel leads 28 of these researchers. It is his first time in command, and the professional stakes come with a personal cost, 5 weeks away from his 2-year-old son. Mapping the final frontier requires scientists to enter a hostile, isolated environment on a strict ticking clock, gathering data before the industry at the surface moves in. While textbook descriptions often portray the deep ocean as a flat, featureless plain, the team's cameras reveal a complex landscape of jagged rocks and manganese crusts shaped by powerful, unseen currents. Observing the bottom is only the first step. To understand the life here, they have to physically retrieve the sediment. This diagram shows the task: lowering a 600-kilogram box corer 5 kilometers down. Every attempt is a 12-hour cycle. The ship drifts and the cable bows under the weight of the currents, making it impossible to tell if the claw made contact. Failure is the baseline here. The cable tangles or the mechanical scoop jams. 5 times in a row, the team hauls the device back to the surface only to find the container filled with nothing but seawater. By 3 a.m., the repetitive failures and the constant swaying of the ship take hold. Sleep deprivation sets in, and the initial excitement of the mission begins to give way to exhaustion. Torben faces the struggle of keeping his team focused. As a leader, he has to manage the growing frustration of 48 people when the ocean refuses to yield a single gram of mud. Deep-sea biology at this scale is a grueling war of attrition against physics, mechanical breakdowns, and human endurance. While the biological team struggles with the depths, geologists on board are looking in the opposite direction, climbing the ship's swaying 38-meter mast. This satellite image shows their target, a sweeping cloud of Saharan dust blowing off the African coast. The researchers climb the mast to trap these minerals, which travel thousands of miles across the Atlantic air currents. Nearby, meteorologists are launching weather balloons to track the atmosphere. To ensure they don't lose their sensors to the wind, they've adapted a low-tech solution from the ship's crew, tethering the balloons with heavy-duty fishing line. These observations reveal a vertical link between the sky and the abyss. The Saharan dust fertilizes the surface water, fueling a bloom of life that eventually dies and creates a biological rain, falling 5,000 meters to feed the organisms in the dark. The atmospheric data is now secure, but the biological evidence remains unconfirmed until Torben's team can successfully recover the sediment from the floor. Understanding the abyss requires tracking the flow of nutrients from the air to the surface and down into the deep, a process that shows how Earth's environments are vertically connected. On the final attempts of the mission, the box core finally holds. It returns to the deck carrying a pristine sample of freezing deep-sea mud. The life inside this mud is so specialized and small that the scientists use a medical X-ray machine to find it. The scans reveal the shifting silhouettes of organisms that spend their lives burrowing through the sediment for food. After 35 days of isolation, the skyline of Fortaleza, Brazil, appears on the horizon. The expedition has crossed the Atlantic. There is a profound sense of relief as the crew prepares to depart. For Torben, the end of the mission means a reunion with his son after 5 weeks of silence. Documenting the abyss is a grueling trade-off of engineering and isolation. This human effort provides the physical evidence required to understand these habitats before they are permanently altered by the industry waiting at the surface.